Hello everyone, this is Aishwarya from Sri Venkateswara College of Engineering. Today in this video you will be knowing what is probability in engineering fields. Introduction to probability. Probability is a measure of a likelihood of an event occurring. It is expressed as a number between 0 and 1, where 0 represents impossibility and 1 represents certainty. Probability is used in various fields such as mathematics, statistics, and decision making. Here are some basic concepts in probability. Sample space is a set of all possible outcomes of an experiment. An event is a subset of the sample space. The probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes. Here is a small example where two coins are tossed, H represents head and T represents tail. There is a list table and a tree diagram based on the two coins are tossed. Theoretical probability is based on mathematical calculation. It assumes that all outcomes are equally likely. The probability of an event A is given by P of A equals number of favorable outcomes by number of possible outcomes. An experiment consists of spinning the spinner once. What is the probability of spinning a 4? The spinner is fair, so all 5 outcomes are equally likely. The probability of spinning a 4 is P of 4 equals 1 by 5. Experimental probability is based on actual observations or experiments. It is calculated by conducting multiple trials and observing the outcomes. The probability of an event A is given by P of A, number of times A occurs, by total number of trials. Experimental probability is the probability of an event happening based on an actual experiment or observation. To calculate the experimental probability of an event, we find the relative frequency of the event. Relative frequency equals frequency of event occurring divided by total number of trials of an experiment. We can also express this as R equals F by N, where R is relative frequency, F is the frequency of an event occurring, and N is the number of trials of an experiment. If we find the relative frequency for all possible outcomes from the experiment, we can write the probability distribution for that experiment. Complementary events. The complement of an event A, denoted as A dash, is the event that A does not occur. The sum of probabilities of an event and its complement is always 1. P of A plus P of A dash equals 1. An event is a set of outcomes in a probability experiment. It is a subset of the sample space. The complement of an event is all the other possible outcomes that are not the event. The complement of an event A is usually denoted as A dash or A power C. P of A dash equals 1 minus P of A. The probability of the complement of an event is 1 minus the probability of the event. Independent events. Independent events are the events that do not influence each other. The probability of two independent events A and B occurring is given by P of A and B equals P of A. Independent event is a term widely used in statistics which refers to the set of two events in which the occurrence of one of the events doesn't impact the occurrence of another event of the set. If two events are independent, then P of A and P of B equals P of A star P of B. Dependent events. Dependent events are events that do influence each other. The probability of two dependent events A and B occurring is given by P of A and B equals P of A. P of B A, where P of B A is the probability of the event B given that event A has occurred. What happens during the second event depends upon what happened before. In other words, the result of the second event will change because of what happened first. The probability of two dependent events A and B is equal to the probability of event A times the probability of event B. However, the probability of event B now depends on event A. P of A B equals P of A into P of B. Mutually exclusive events. Mutually exclusive events are events that cannot occur at the same time. The probability of two mutually exclusive events A and B occurring is given by P of A and B equals 0. The probability of either event A or event B occurring is given by P of A or B equals P of A plus P of B. Conditional probability. Conditional probability is the probability of an event occurring given that another event has already occurred. The probability of event A given event B is denoted by P of A B and is given by P of A B and P of A and B divided by P of B. Conditional probability allows us to update our probabilities based on new information. Now let us know what is probability distribution. Probability distribution describes the likelihood of each possible outcome in a random experiment. They can be represented graphically using histograms, bar charts, or probability density functions. Common probability distributions include the normal distribution, binomial distribution, and Poisson's distribution. Now let us see what is Bayes' theorem. Bayes' theorem is used to update probabilities based on new evidence. It calculates the conditional probability of an event A and event B using the conditional probability of B given A and prior probabilities of A and B. Mathematically, it can be expressed as P of AB equals P of BA. Random variables. Random variables are variables that take on different values based on the outcomes of a random experiment. They can be discrete, taking on a countable number of values, or continuous, taking on any value within the range. Random variables are used to model and analyze various probabilistic phenomena. Expected value of a random variable. The expected value of a random variable is the long-term average value it takes on. For a discrete random variable, it is calculated as the sum of each value multiplied by its probability. For a continuous random variable, it is calculated as the integral of each value multiplied by its probability density function. Standard deviation. Variance measures the spread or dispersion of a random variable. It is calculated as the average squared difference between each value and the expected value. Standard deviation is the square root of the variance and provides a measure of the variability of a random variable. The expected value of a random variable gives the average value of the distribution. The standard deviation shows how spread out the data is. You can think the standard deviation as the average distance of the data from the average. The variance is the square of the standard deviation. Let us know what is central limit theorem. The central limit theorem states that the sum or average of a large number of independent and identically distributed random variables approaches a normal distribution regardless of the shape of the original distribution. This theorem is widely used in statistical inference and hypothesis testing. Finally, let us see what is the applications of probability. Probability is used in various real-life applications such as insurance, finance, weather forecasting, sports, analytics, and risk assessment. It helps in making informed decisions, assessing uncertainty, and predicting outcomes. By understanding probability, we can better understand the world around us and make more rational choices. Probability is a fundamental concept in mathematics and statistics. It allows us to quantify uncertainty and make predictions about the likelihood of events. By understanding probability, we can make better decisions and analyze various phenomena in the world. Thank you.